Yeah, hello everyone. Yeah, myself, Venkata Swami, and working as a associate professor and additional control of examinations in Mlritm. So let's start off this polymeric materials. Now we are going to discussing about rubbers materials. This is the rubber materials. Now we are going to discussing. So what is mean by rubber? In general, in our daily life, we are using many rubber materials, but we don't know what are the important properties of the rubber and how it is made up of with respect to the what are the different ingredients, etc. Now, so what is rubber? And these rubbers, which are also called as here elastomers. So what is mean by elastomers? Here elastomers are nothing but these are also one type of organic high polymeric structures. Simpler way, these are the organic high polymeric materials which are having some elasticity properties or plasticity nature. That is the reason, so high polymers, some of the high polymers which are possessing plasticity natures, and so that such type of polymers we can call as here elastomers. And these elastomers which are undergo with long elongation, that is elasticity nature, when we are applied some stress, therefore it is going to be a very tough, very strong polymer, and if you remove the stress, and it is going to be a virginal shape on by releasing the stress. Such type of polymers we can call as elastomers. Simple way, the elastomers are nothing but these are the one type of organic high polymers which are possessing elasticity nature or plasticity nature, or upon by using some stress or by using them under stress, so the polymeric chains are held together very tightly, and on releasing stress, it is going to be converted into a virginal coiled helix structures. So that such type of polymers are we can call as elastomers. So the property of elastomers is known as elasticity, and this is the arises due to the coiled helix structures of polymeric structures. So these are the many rubbers we can see here for the example for these rubbers. And based on the sources, the rubbers usually we can classify it into two categories. One is the natural rubbers and second one is the artificial rubbers. The first point, the natural rubber, which is also called as primary rubbers, and the artificial rubbers which are called as secondary rubbers. Let's see the first one, natural rubber. So natural rubber, and the rubber which is obtained from the natural sources like plant materials, some wood materials of the nature, and these rubber materials which is obtained from the nature, which is called as natural rubber. So the general we use it to terminology here nature. Nature is nothing but the plant materials. So that these rubber also we will get from one type of plant material, and that type of tree we can call as Hevia brasiliensis tree. Hevia brasiliensis tree, and from this Hevia brasiliensis tree, so we are getting the natural rubber in the form of latex. What is that? In the form of latex, and that latex which is like latex is nothing but it is a one milky of emulsion. You just assume that this tree name is Hevia brasiliensis tree. And from in this tree, so we are getting the latex, we are getting the rubber. It is a white fluid which is called as latex, which is called as a milky of emulsion, which is called as a milky of emulsion. And this milky of emulsion, which is consisting of 95% of hydrocarbons, and remaining the 5%, that is impurities. Remaining 5% impurities. So that's why the natural rubber which is obtained from the one type of tree, and the tree name is Hevia brasiliensis tree, and from in this Hevia brasiliensis tree, you are extracted the rubber in the form of that is we will get a liquid, a white color liquid, which is we are getting from the tree in the form of latex. Latex is nothing but a milky of emulsion, and that milky of emulsion which is consisting of 95% of saturated hydrocarbons and remaining 5% of impurities. When during the observe of the synthesis of this, when we are looking forward about this rubber, the natural rubber which is also called as polyisoprene. The natural rubber which is also called as polyisoprene. Usually the rubber is nothing but it is a one type of organic high polymer. So polymer, as you know this, the polymer is nothing but it is a made up of the combination of two or more monomers, and it will lead to the formation of a polymer, a giant molecule. A macro molecule is said to be a polymer. So that the rubber is also one type of polymer. That's why, so the another name for the natural rubber is polyisoprene. So the monomeric unit is isoprene. The monomeric unit is isoprene, and the isoprene in the another name is here. So 2-methyl 1,3 butadiene. This structure is isoprene. 2-methyl 1,3 butadiene is called as isoprene. So this 2-methyl 1,3 butadiene isoprene units which are undergoes, because 2-methyl 1,3 butadiene, it's an unsaturated chemical compound. As we know that unsaturated chemical compounds are participated in addition polymerization. Here also this isoprene units which are undergoes addition polymerization in the presence of a temperature or in the presence of like a pressure, and finally it will lead to the formation of a polymer, and that polymer we can call as a polyisoprene, that we can call as natural rubber. But my dear students, you should remember one point here. Many isoprene units are which are undergoes addition polymerization, but here isoprene units are which are undergoes 1,4 addition. Which type of addition, Anna? 1,4 addition polymerization. So what is mean by 1,4? There is a first carbon of one isoprene unit and the fourth carbon of what is that? One more isoprene units are they combined with each other, and it will form a coiled helix structure of a polyisoprene, and which is called as natural rubber. So that here natural rubber is a high polymer of isoprene, that is 2-methyl 1,3 butadiene. So that the polyisoprene exists in two geometrical isomerism. Yeah, one more important point here we have to discuss. So polyisoprene units, the polyisoprene polymer which is available in two geometrical isomerism. One is the cis form of polyisoprene and trans form of polyisoprene. As we know, what is meant by cis? The cis is nothing but, so here two functional group. For example, here the C double bond is there. So here, so CS3 and the hydrogens are, if the CS3 group and the hydrogen groups are located in the same side, then we can call as cis polyisoprene. So whereas in the case of trans polyisoprene, so this what is that? This CS3 and hydrogen groups are which are located in opposite direction. That's why. So this is this type of geometrical isomer we can call as trans polyisoprene. So cis polyisoprene which is in elastic in nature, and the trans polyisoprene which is in non-elastic in nature. we have, so here when we're seeing this, when we observe this reaction, so the natural rubber, the polyisoprene existing in two geometrical isomerism form. One is the cis polyisoprene and second one is the trans polyisoprene. So here, next point here, vulcanization. So why should we discuss about this vulcanization of rubber? So what is the reason behind that? Because of the raw rubber, that is the natural rubber, very little useful because of it has very undesirable properties. So what are the undesirable properties? Nothing but low tensile strength and possesses elasticity only over a limited range of temperature. And also the natural rubber, when we are keeping in some water, it will easily absorb the water molecules. And also the natural rubber, when we are exposed to the atmosphere, so what will happen here from the natural rubber? So it is consisting of unsaturated double bond. So this unsaturated double bond, it will easily reacts the oxygen. Therefore, there will be a formation of epoxides in natural rubber. So when epoxides are formed in natural rubber, so from the natural rubber, it will give some smell. So due to this, all these disadvantages are present in the raw natural rubber. That's why Charles Good in 1839, one of the famous scientists, he did some experimental studies on this natural rubber to enhancement of the properties of natural rubber. That's why, so during his experimental studies, Charles Good in 1839, he took one natural rubber, one raw rubber, he added some chemical compounds. He added many chemical compounds and he observed that, so how and which chemical compound which is suitable for the enhancement of the properties of the natural rubber. And after several days, Charles Good, a scientist, he found that a sulfur suitable chemical compounds. What is that? Sulfur suitable chemical compounds are one of the important chemical compound. He added to the natural rubber and he found the properties of the natural rubber. So that he identified that, so sulfur is one of the suitable compound to improve all the properties of the natural rubber. That is, the tensile strength is increasing, the swelling nature is decreases, and reacts with the oxide. There is no formation of epoxides, there is no bad smells, there is no toxic nature. So all these properties are tremendously increased when we add, that is, sulfur suitable compounds to the natural rubber. That's why here vulcanization of rubber is nothing but to improve the properties of natural rubber. Charles Good in 1839, he added sulfur suitable chemical compounds to the natural rubber to improve the properties of natural rubber, is called as vulcanization of rubber. In the simple way, the heating the rubber with sulfur, heating the natural rubber with sulfur is called as vulcanization of rubber. So why should we discuss about the vulcanization? Is nothing but to improve to enhancement of the important properties of the natural rubber. So that's why, so we should know about this vulcanization of rubber. So in order to give more strength and more elasticity, the natural rubber is heated with sulfur or sulfur compounds at 100 to 1400 degrees centigrade or 140 degrees centigrade a few years. Third point, the sulfur which combines chemically. Yes, so you added the sulfur chemical compounds to the polyisoprene units. So what will here, the sulfur chemical compounds are there chemically combines at the unsaturated double bond. The sulfur atoms are there chemically combines to polyisoprene units. There will be a formation of a chain, cross-linked chains. See here, the sulfur combines chemicals at the double bonds of the different rubber springs and provides a cross linkages between the chains. There will be a formation of cross linkages so that polymer is going to be very strong. That's why, so here see, this is the one polyisoprene units, this is the another polyisoprene units. You added the sulfur chemical compounds, and these sulfur chemical compounds are, it will combines at unsaturation, double bonded, and finally there will be form a sulfur cross linkages takes place in between the two sulfur polyisoprene linkages. See, this cross linkaging during vulcanization brings about a stiffening of the rubber. Stiffening is nothing but very strong by anchoring the consequently preventing the intermolecular movement of rubber spring, and this process is known as vulcanization of rubber. So the amount of sulfur added determines the extent of the stiffness of the vulcanized rubber. In order to maintain the stiffness of the rubber, we should add some required amount of sulfur, and that process we can call as vulcanization of rubber. In the simpler way, so heating the natural rubber, heating the polyisoprene units with the sulfur chemical compounds is called as vulcanization in order to maintain the good important properties of the natural rubber, and is called as vulcanization process. So what are the advantages for this vulcanization process? Let's see. So vulcanized rubber, not vulcanization, vulcanized rubber. After vulcanization process, you are getting the rubber is there, na? So that rubber is called as vulcanized rubber, has good tensile strength and load bearing capacity. Second point, vulcanized rubber has excellent resistance, and it has a better resistance to moisture and oxidation and abrasion, and it has a resistance to organic solvents like a carbon tetrachloride and benzene or petrol, etc. And it has a good elasticity. And sixth point, it has a good electrical insulated. So all these 6 points are the important properties of the natural rubber is improved when we add a sulfur suitable chemical compounds to the natural rubber. So these are some of the important advantages of vulcanization of a process or vulcanization of a rubber. Next, let's see the applications. So this vulcanized rubber we can use it in manufacturing of tires, automobile tires. So the tank linings in the chemical plants where corrosive chemicals are stored in the prepared from rubber. To reduce the machine vibrations, rubber is used for sandwiching between the two metal surfaces. And the foam rubber is also used for the making cushions and the mattresses and the padding, etc. And the toys and the sports items are manufactured from the natural rubber. So these are some of the important applications of this vulcanized rubbers. So this is the part of natural rubber. So based on the sources, the rubber we have classified two types. One is the natural rubber and its vulcanization process. And the second category is synthetic rubbers, which are also called as elastomers, or which are also called as artificial rubbers. So among these artificial rubbers, we have the good examples. One is the Buna-S rubber, butyl rubber, and the thiacol rubbers. These are the three important elastomers. These are the three important synthetic rubbers. So among this, first one is Buna-S rubber, which is also called as styrene rubbers. So Buna-S rubbers. Bu. So Bu stands for butadiene, and Na stands for sodium, and S stands for styrene. So all monomers are, so rubber is nothing but it's an organic high polymer once again. So it is a polymer, so that the polymer is made up of from the monomers, and now we are using the monomers are butadiene and the styrene and the sodium a catalyst. So all these monomer units are different. So different types of monomers are, it will lead to the formation of copolymer. That's why, so here Buna-S rubber is a copolymer. First point, please note down. So Buna-S rubber is a copolymer. Why? Because of, so monomers are different. That is butadiene and sodium, which is acts as a catalyst, and S stands for styrene. So all these three chemical compounds are different. That's why, so different monomers are involving in polymerization process so that it will lead to the formation of a copolymer, and this polymerization process we can call as copolymerization. Very good. So first point, it is a copolymer of butadiene, that's 75%, and styrene 25%. And it is prepared by copolymerization of butadiene and styrene in the presence of sodium and catalyst. So in BUNA S, so Bu stands for butadiene and N stands for sodium, which is acts as a catalyst, and S stands for styrene. So it is also called as, one more name is there, Nana. So it is also called as GRS rubber. That's a governmental regulated styrene rubber or governmental rubber styrene rubber. Or also we can call as SBR, that's a styrene butadiene rubbers. So let's see a synthesis preparation of this rubber, BUNA S rubber. So first monomer is butadiene, 1,3 butadiene, and the second one styrene. Second monomer is styrene, that is a vinyl benzene, which is also called as vinyl benzene. And here sodium acts as a catalyst in the presence of temperature, in the presence of a pressure, in the presence of a copolymerization, and it will lead to the formation of BUNA S rubber. Same, having this unsaturation, double bond is going to be converted into the single bond is going to be converting into double bond. Just blindly you fix that. That's why here this BUNA S rubber, which is involved in copolymerization, and then finally it will lead to the formation of BUNA S rubber. Let's see the properties of this BUNA S rubber. It's a very strong polymer, it's a very tough polymer, and this rubber is also can be vulcanized, similar to natural rubber using of sulfur or sulfur chemical compounds. And it is a good electrical insulator. You just remember this BUNA S rubber is also, we can use as a good electrical insulator, and it possesses excellent abrasion resistance. It is also resistant to chemicals, and it doesn't react with any chemical compounds, but easily spills in oils and easily attacks by even traces of ozone which is present in the atmosphere. So it possesses high load bearing capacity and resistance. So these are some of the important properties of what is that BUNA S rubber. Let's see the applications. So the major applications of the BUNA S rubber is the manufacturing of tights, similar to natural rubber or vulcanized rubber, and it is used in footwear industry for making shoe soles and footwear components. One of the important application. Third important application is it is also used for making wires and cables and as well as insulators. It is also one of the important application, and is also used for the production of tank linings in chemical industry. We are seeing here one of the image of this tank linings in chemical industry. These are some of the important applications of what is that BUNA S rubber. Next, a second synthetic rubber is elastomer is thiocol rubber. This is also a lab experiments. Thiocol rubber. Thiocol is nothing but sulfur. Thio means sulfur. So that thiocol rubber, which is also called as polysulfide rubber. So polysulfide rubber is also one type of polymer. So before we are going to discussing about this thiocol rubber or polysulfide rubber, this thiocol rubber which is undergoes condensation polymerization. And the thiocol rubber is synthesized from condensation polymerization of different types of monomers. So for the preparation or for the synthesis of thiocol rubber, we need to collect one sodium hydroxide pellets. Second chemical compound is sulfur powder. Third chemical compound is ethylene dichloride, or which is also called as 1,2 dichloride. Next, you take some of the important what is the 30 to 50 ml of water. So these are the chemical compounds are required for this synthesis of thiocol rubber. So here 1,2 dichloroethane. This is the sodium polysulfide which are undergoes condensation polymerization. As you know, the condensation polymerization is nothing but elimination of a smaller molecules from the monomers which are having some polar groups, and finally it will lead to the formation of a strong polymer, a rigid polymer which is called as condensed polymer. And in this case, so we got this here, thiacol rubber, and here the smaller molecule is sodium chloride. So let's see the important properties of this thiacol rubber. So thiacol rubber possesses very strength and impermeable to gases. This rubber cannot be vulcanized. Yeah, this is the one of the important point. Bunized rubber we can vulcanized. Butyl rubber also we can vulcanized. Natural rubber is also we can vulcanized with the adding of sulfur chemical compounds. But here thiacol rubber we cannot be vulcanized because of the already the sulfur atoms which are cross linkages takes place in between the two polymeric units. So that, and it cannot form very hard rubber because it possesses a good resistance to mineral oils and fuels and the oxygens and the solvents, ozone and sunlights. It is also resistant to the action of petrol lubricants and organic solvent. That is nothing but it doesn't react with this. So petrol or petrol lubricants and organic solvents. So one of the major important application is thiacol rubber or polysulfide rubber is which is cannot be vulcanized rubber by adding of sulfur. And applications. So the fabric coated with the thiacols are used for the barrage balloons and life rafts and jackets. Mostly we are looking here, we are seeing here one image you can observe, which is used for making seals for the printing notes, and thiacol rubber which is mixed with the oxidizing agents which is used as a fuel in rocket engines. So these are the one of the major three important application of this. What is that? Thiacol rubber. Yeah, you can see here some of the references here, three references you can observe. Thank you. And this is the conducting polymers. Next class, we will discuss about the conducting polymers. Thank you. Thank you so much.